In this discussion, we are going to look at application of confidence intervals. So the confidence intervals help us to take confidence in the mean that has been obtained from statistics, that actually that mean can be reliable. Okay, and the confidence intervals are going to give us the range within which that mean is going to be lying. So you can be given that the mean is a particular value, but it should go, it should never go below a particular value, and it should never go beyond a particular value. So that's what the confidence intervals do. So the question that is given to us is that a random sample of 50 males mean average daily intake of dairy products equal to 756 grams. Okay, and with the standard deviation 35 grams. Find a 95% and 99% confidence interval of population average new. So they want us to determine the confidence interval for this new, or the mean of the population. So what does this call us to do? This n is greater than the n here is greater than 30, so we are going to use a z value. We are going to use a z value. But first of all, the confidence interval is always going to be, okay, it's going to always be the sample, okay, the sample mean plus or minus z times the standard deviation of the sample, okay, let me take the standard deviation of the sample, that is s divided by square root of n. So this ratio is what others call the standard error value. So you have to determine, first of all, the mean is known, but you know the mean, you know the standard deviation, but you don't know the z value. So our task here is to look for the z value. First of all, let's begin with for a 95% confidence interval. So for this one, we are going to look for get a z value at 5% level of significance. So let's go and look for that z value. Let's look for that z value. The z value that corresponds to a probability of 0.05, because if it corresponds to 0.05, then it is also giving us the 95% confidence. 95% confidence has a 5% level of significance. And we are talking about the probability being 0.95. Now, the 0.05, what is its z value? So 0.05. So 0.05, we need to ask ourselves, 0.05, you can check. Okay. Now, the 0.05, let's first draw our the normal distribution curve, curve will be like this. So this 95% level of confidence will be between a value of 2.5% and a value of 2.5%. So what do we do with that? In between here, this proportion is going to be 95. This other side is 0. Okay, it's 2.5. This side is 2.5. In the middle is 95 to make an area equivalent to 1, because the probability under this normal distribution curve, the total must be 1. But now if we are to get the 95, we are going to be looking at below and above the mean. So below and above the mean. So 2.5, 2.5 below the mean. So what is going to give us the critical value of Z is going to be at 2.5 and the critical value at 2.5 the other side. So let's go ahead and look for that value that gives us 0.025. So we find that the one that gives us 0.025 is here. So that is 0.025 corresponds to negative 1.9, because this is 0.6, which is negative, then we add the negative 1.9. So let's go and look at our problem. So obviously this is going to be 1.96 and this is going to be negative 1.9. So for the 95% confidence interval, the 95% confidence interval, we shall find that that confidence interval is going to be the mean. Mean is known, and that mean is 756. So we have 756. So plus or minus the Z value. The Z value that we are going to take is, we are going to take 1.96. We multiply it by S, which is the standard deviation of the sample, and it was given. The sample mean was given also 756. So S is 35 divided by square root of N, whereby N is 50, because we are told there are 50 males. So we calculate that. That is 756. Okay, let's first calculate that. 1.96 times 35. We divide it by square root of 50. So this is going to be 756 plus or minus 9.70. So let's see. So 1.96, if we multiply by that, get this minus this value. So minus 756. So if I get this minus 9.7, I get 746.3. And this is supposed to be less or equal to, this is supposed to be mean, which is the population in U. So the population in U is going to be in between that value. Less than, okay, less than or equal to, now 756 plus that. 756 plus 9. So finally, the value that I have here is 765.7. So the confidence interval, the 95% confidence interval, 95% confidence interval for population mean new is 746.3. I can say comma 765 and I give it like that, meaning 746.3 is inclusive and 765.7 is inclusive. Let's look for the 99% confidence interval. What we are going to do is to look for get Z, okay, Z value at 1% level of significance. So this is going to be 0.01. But if I divide it by 2, this is going to be 0.05 0.01 divided by 2. So this is going to be 0.5. So if I draw my normal distribution curve, I'm going to look for the value that corresponds to 0.05 here, that is the alpha, and here 0.0. So what is in here is going to be the 99% confidence interval. So let's go and check in our tables. We are going to look for the Z value that corresponds to the 0.005. So where is that value? The one which is close to 0.05, we have that, and we have this. So probably we can take this, and that will be -2.5. So the Z value that corresponds to a value which is approximately 0.005 is -2.57, because this is 2.5 negative and above there is 0.07. So we go and put that value here. This is this is positive 2.57. This is negative 2.57. So the 99% confidence interval will be the Z value, which is critical. We multiply by S divided by N. So this is equal to, our Z value is already given as 2.57. We multiply by 35 divided by √50. But remember, we are supposed to add the sample plus or minus. Okay, this is the sample mean plus or minus. So the sample mean here, this is 99% confidence interval, will equal to 756 plus or minus that value. So this is 2.56, 7 multiplied by 35 divided by square root of 50. So here our value, we said 2.57 times 35 divided by square root of 50, and the value that is calculated is 75.6 plus or minus 12.72. So the lower value will be this minus that, and the higher value will be 75.6 plus that. So the value here is going to is 743.3 less or equal to mu less or equal to 756 minus 756 plus 12.72, and the value is 768.7. So the 99% confidence interval for this mean of the population is going to be 743.3. It is going to be between 743.3 inclusive and 768.7 inclusive. So that is the range within which the population mean is going to be. But remember, we have calculated it using the sample mean. So we use the sample mean and be able to estimate the range within which the population mean is. And that is the function of, or the advantage of knowing how to get the confidence interval. So if there is no question,